Assalamualaikum and good day all. So we are coming back to the topic of atoms, elements, compounds. Assalamualaikum and good day all. Today we are going to continue with the topic of chemical bonding. And before we proceed, so these are the attendances. Please fill in this attendance for occurrence 1 and this attendance if you are from occurrence 2. So I have also included the link of the attendances in the spectrum. So you can either scan from here, or you can also look at the link in the spectrum. Okay, so in the last class, we have talked about atoms, elements, mixtures, and compounds. So I hope that you guys are able to distinguish between them, and also see that some of them are actually two things instead of one. So today we are going to continue to a deeper understanding of each of these. So based on what we have learned before, you can see that there are some distinguished differences between atoms, elements, compounds, and mixtures. But then, today we are going to look at what is the real difference, meaning what is the thing that is making them so different. Atoms tend to arrange themselves so that they will exist in the most stable patterns possible. Okay, so when I say most stable, it means that it has the lowest energy. You can think of it as if we are trying to do something, and we tend to do things in the easiest way possible, where we are actually using the least amount of energy. So the same thing goes with atoms. When they are coming together, they want to be in the lowest energy state possible. So they have a tendency to complete or fill their outermost electron orbital. So remember, we have looked at the fact that atoms or elements, they have different numbers of electrons around them. So the different number of electrons around them result in different stability. So in order for them to fill or to complete their outermost electron orbitals, in order for them to be the most stable state possible, so they usually they tend to join with other atoms to do that. Let us think of the easiest example. I would say probably hydrogen. Okay, so hydrogen has only one electron on it, so you can say that that is its outermost orbital. And hydrogen by itself is unhappy because it has only one electron. So you can say that the first orbital or the outermost orbital is half filled. So since it is half filled, okay, it has high energy. Okay, therefore it is unstable. Okay, so you can compare that to another atom. For an example, the easiest would be helium. So helium has 2 electrons on it, or 2 electrons on its outermost orbital, and this is the maximum number of electrons in the first orbital. So you can say that the orbital is fully filled, I would say. Okay, and And because of that, it has low energy and it is stable. Okay, so in other words, the orbital is fully filled and is stable, therefore they react differently. So hydrogen atoms, or you can say the unstable atom, would love to be as stable as helium. Therefore, they'll try to find ways to be more stable. Okay, so again, this is done by them making chemical bonding or making new chemical bonds. Okay, and this is done with another atom. If we refer to, let's say, the energy diagram, so this is an energy diagram. So as its name, the y-axis is representing energy, and the x-axis is usually referring to reaction coordinate, or how does two atoms coming together to form a new bond. Okay, so you can say that the energy of an unstable atom, so let's say in this case we are talking about one hydrogen, so it is initially high. So let's say that that is its energy. Okay, and the higher a species in an energy diagram, the less stable it is. Okay, so through chemical bonding, okay, the energy decreases until it forms molecule. So this is, for an example, H2 molecule. Okay, so the energy is much lower as compared to the hydrogen atom. And again, this happens through chemical bonding. Okay, so chemical bond is actually the force. Yeah, you can say that it is a force that hold atoms in collection, known as molecules, or a force that holds atoms collectively. Okay, so this thing, when the atoms are together collectively, so this is known as molecule. So that is what chemical bonding is, and that is the reason why, or the real difference between atoms, elements, mixtures, and compounds. So this is what I have explained before. So in chemical bonding, atoms tend to arrange themselves in the most stable patterns possible, which means that they have a tendency to complete or fill their outermost electron orbits. They join with other atoms to do just that. A stable compound occurs when the total energy of the combination has lower energy than the separated atoms. For example, hydrogen and hydrogen. So both of these, they have high energy. Okay, but then when they combine together to form H2, then they have a lower energy. So the force that holds atoms together in collection, known as molecule, is referred to as chemical bond. So there are two main types and some secondary types of chemical bonds, and we are going to look at them. So the primary types of chemical bonds are ionic bond and covalent bond. So we're going to look at both of them. And the secondary types of chemical bond are polar bonds and hydrogen bonds. So actually there are two other most common secondary types of bond, which are the metallic bonds and also van der Waals forces. Okay, but we are not going to look at these two. We are only going to look at polar bond and hydrogen bond. Okay, so first let us look at ionic bond. Okay. Ionic bond always involves transfer of electrons. Okay, where one atom gains and one atom losing electron. Okay, so for an example, if you have A and B, so you have two atoms. Okay, so A and B, they won't behave the same. One of them, for example, A will gain electron, extra electron, and B will lose electron. So that's the characteristic of ionic bond. Okay, so this is motivated by their desire to have the similar electron configuration as noble gas. For example, like hydrogen wants to be like helium. They always try to fill in their outermost orbitals only. Okay, so for an example here, we have sodium. Sodium, initially it has only one electron on its outermost orbital, and sodium is trying to react with fluorine. Okay, so fluorine has 7 electrons on its outermost orbital. Okay, so 1 electron on outermost orbital, and fluorine has 7 electrons on outermost orbital. Okay, so since both of them are not yet achieving the fully filled outermost orbital, therefore they tend to react. Okay, so in this case, sodium will be happy to donate its 1 electron, and fluorine will be happy to accept its 1 electron. Okay, and because of that, when this happens, okay, so remember that the atoms originally is just neutral. Okay, so when sodium lose 1 electron, okay, because electron is negatively charged, therefore it becomes positive because it has lost 1 negative. Okay, and this is known as cation. On the other hand, fluorine has accepted 1 electron. So now initially it was neutral, then it accepted 1 electron, so it becomes extra negative. So it becomes negative overall. Then this is known as anion. Okay, so in ionic bond it involves 2, negative ion, anion, and positive ion, cation. Okay, so that is the characteristic of ionic bonding. The second one that we are looking at is covalent bond. Okay, so covalent bond is actually the most talked about, or the most discussed about when we are talking about organic molecules. So, our covalent bond was first proposed by G.N. Lewis in 1916. Okay, so he proposed that atoms combine in order to achieve a more stable electron configuration, just like what we have talked about before. But rather than one accepting and one donating, covalent bond talks about the sharing of the electron. So the key word is sharing. Okay, between two atoms. Okay, so for an example, okay, we are looking at hydrogen atom. Okay, so hydrogen atom, 2 hydrogens, and both of them has 1 electron, 1 extra electron on it. So rather than one donating and one accepting, covalent bond happens when they are sharing the 2 electrons. So basically, these 2 electrons doesn't belong to only one hydrogen. It is actually being shared equally between these 2 hydrogens. Okay, so both of them achieve the maximum or the fully filled outermost orbital because they are all sharing the same electrons. So basically, the electrons will just move around it, okay, as a whole equally between these 2 hydrogens. So when 2 hydrogens atoms are joined in a bond, okay, each has a filled valence shell of 2 electrons, thus achieving stability. So now they become stable. Okay. So even though in this illustration you can see that the 2 electrons are like placed in the middle of these 2 atoms, but in real theory it doesn't happen that way. So in real theory, these 2 electrons are actually evolving around these 2 nuclei. Okay, so by doing so, the electron pair gives each hydrogen an electron configuration analogous to helium. So 2 electrons each, and which is similar to a noble gas. Another example that I want to share is fluoride atom. Okay, before we look at fluoride atom, if you still remember, in the previous slide we have talked about the combination between sodium and fluoride. So in this case, sodium donates 1 electron and fluoride accepts 1 electron. So this was ionic bonding. But then when 2 fluoride atoms reacting together, they no longer donate and accept. Instead, each of them has 7 electrons each. Okay, so when they combine together, they are sharing this 1 electron from each other, resulting in a shared 2 electrons. Okay, so each of them now has 8 electrons each. Okay, so this kind of sharing is resulting in covalent bonding. So you can see that F can form ionic bond and F can also form covalent bond. So when they share these 2 bonds together, these 2 electrons together, they are achieving a stability similar to a noble gas known as neon. So if you look at the periodic table, neon has 8 electrons on its outermost orbital. Okay. There are 2 kinds of secondary bonds that contributes to covalent bond, which are the polar bonds and hydrogen bonds. But as I said before, there are other secondary types of bonding, but we are not going to look at them. We are only to look at polar bond and hydrogen bond. Okay, first we look at polar bond. Polar bond is also sometimes termed as polar covalent bond because, as I said before, it also contributes to covalent bond. So the term covalent here, even though it's polar, the term covalence here actually refers to the meaning that there is sharing happening between the atoms. But the term polar here means that so the term polar here means that there is a unequal electron distribution between the two atoms. Okay, so before this we talked about covalent. Covalent, as I said before, it's an equal sharing between two atoms like hydrogen and hydrogen, fluoride and fluoride. But this time polar covalent, even though the atoms, the electrons are being shared, but the electron distribution is not equal between the sharing atoms. So a polar bond is actually, you can say that it is an intermediate case between ionic and covalent bonding, with one end of the molecule slightly negatively charged and the other one slightly positively charged. Okay, let us look at an example. The easiest example will be water molecule. Okay, so this is water molecule. So we have H2O, HO. Okay, so that is a water molecule. So water molecule, in this case, the oxygen has 6 electrons on its outermost orbital, and the hydrogen has 1 electron on its outermost orbital. Okay, so what happened was they are sharing the electrons, so that oxygen has 8 electrons in total. Hydrogen also has 8 electrons in total. Okay, so they are sharing the electrons, but okay, the oxygen atom has more electrons, so we can say that the electron spends more time on the side of oxygen, on oxygen side, you can say like that. Okay, and because of that, the electron spends less time on hydrogen side. Okay, so because of that, because they are not spending an equal amount of time on each of the side, so they have intramolecular polarity, where now the molecule becomes unevenly charged. Even though water molecule is neutral, but it becomes unevenly, or the distribution of the electrons become unequal. So on one end of the molecule is slightly negatively charged and the other end is slightly positively charged. So in this case, on the side of oxygen, it's slightly negatively charged. Usually we represent it as delta negative. And on the side of hydrogen, it's slightly positively charged. We say that it is delta positive. Okay, so this is what is shown here. Oxygen delta negative, hydrogen delta positive. But you have to be very clear that even though this is delta negative, this is delta positive, they are actually still neutral. Okay, so you can't say 2 delta positive or 1 delta negative. No. Okay, it's just that one side is delta negative, one side is delta positive, but they are neutral. Okay, so the second one is hydrogen bond. So this is an illustration of hydrogen bonds that exist in water. Okay, before this we've talked about the unequal distribution of electrons in a water molecule, and it is known as polar covalent bond. But the interaction of oxygen and hydrogen of different water molecules is known as hydrogen bond. So if you look closely, so this is the interaction between hydrogen and oxygen. So hydrogen bond is actually an electrostatic attraction between a proton to a more electronegative atom, example FO and N, and another adjacent atoms bearing a lone pair of electron. So in this case, this is an interaction between molecules. So we call that intermolecular because more than one molecules are involved. But in some cases of big molecules where the proton is close to a more electronegative atom, hydrogen bond can also exist within the different parts of a single molecule. So it can be between two molecules, or it can also be within one molecule. Okay. So why do this happen? Okay. So of course, as its name, hydrogen bond can only happen if it involves hydrogen. So there must be hydrogen. Okay. But there are another two important conditions for hydrogen bonding to happen. First, it has to be bonded with an atom with high electronegativity. Okay, so some examples, as I said before, are fluorine, oxygen, and nitrogen. So electronegativity is actually a measure of how strongly an atom in a molecule is able to attract electrons to itself. So to pull electrons to itself. Two examples of that I've shown here. Oxygen electronegativity is 3.44 and nitrogen electronegativity is 3.04. So that is actually high. That's why they can form or they can attract electrons to themselves. Okay, so H can form hydrogen bond with oxygen, and H can also form hydrogen bond with nitrogen. But because of the value for nitrogen, or the electronegativity value for nitrogen is higher, we can say that the hydrogen bond for oxygen is greater than the hydrogen bond with nitrogen. The second condition in order for hydrogen bond to happen is that the atom has to be small. Okay, the electron has to be small. Reason is when hydrogen atoms are joined in a covalent bond with a small atom, and it has to have high electronegativity such as FO and N. So the partial positive charge of the hydrogen is highly concentrated because of its smaller size. For an example, okay, if you imagine two atoms, okay, one is smaller, one is larger, and they have the same value of electronegativity, for an example, the same initial value of electronegativity. So if the size of the atom is smaller, then the impact is larger. Okay, so the larger impact is allowing for hydrogen bond to happen. For an example, just for comparison purpose, if you look at this picture, so this is the size of nitrogen as a comparison to the size of chlorine. And if you look, and they actually have the same electronegativity. So nitrogen and chlorine, both of them has the electronegativity of 3.0. Okay, but due to the smaller size of nitrogen as compared to Cl, the electronegativity effect is more prominent. So in this case, the hydrogen bond with nitrogen is much larger than the hydrogen bond that could possibly happen with Cl. So hydrogen bonding wise, it is more prominent in the interaction between hydrogen and nitrogen. Okay, so in conclusion, when you have so in conclusion, there are two conditions for hydrogen bonding. One is when you have high electronegativity, and second is when you have a smaller size of atom, and that results in a stronger hydrogen bonding. And finally, I would like to just add on that the attraction of hydrogen bond can be about 5 to 10% of the strength. Sorry, the attraction of the hydrogen bond can be about 5 to 10% of the strength of a covalent bond. So it's not that strong, but it is strong enough to have a lot of impact when we are talking about reactivity or how much the molecule react. Hydrogen bond is also a major contributor for the unique properties of water. Remember last time we have talked about water molecule. Okay, so a lot of water properties are due to the hydrogen bond. So some examples of the properties are hydrogen bonded, such as the surface tension, specific heat, and heat of vaporization. Okay, so due to this attraction of hydrogen bonding, molecules of water join together transiently in a hydrogen bonded lattice. Hydrogen bonds have only about 1 to 20 the strength of a covalent bond, yet even this force is sufficient to affect the structure of water, producing many of its unique properties such as high surface tension, specific heat, and heat of vaporization. Hydrogen bonds are important in many life processes such as in replication and defining the shape of DNA molecules. So just a quick introduction, okay, of organic compounds. So organic compounds are compounds containing carbon and usually hydrogen. Okay, so compounds that are not organic are called inorganic. Some very simple carbon compounds, particularly those not containing hydrogen, carbon dioxide, chalk, and other carbonates, for example, are honorary inorganic compounds because they are so popular. Okay, so examples of organic compounds that you can easily find is cholesterol. So that's just one example. Carbohydrates. So those two are just some examples that I would like to share. So finally, so there's a video on YouTube that I would like to share with you guys, so you guys can watch this. Or I will also put up the link to the video on Spectrum. That's all for today. Thank you.